with 1-1 is literally one page. We're just going to talk about graphing ordered pairs and kind of our quick reminder on how to graph ordered pairs or coordinates. We'll be using the rectangular coordinate system that's also called the Cartesian coordinate system. Same thing. It is important to know your quadrants. So your quadrants start with quadrant 1 in your upper right-hand corner, and then it goes counterclockwise. So it goes around to the left. So 1, 2, 3, 4. And then ordered pairs, it's always going to be, well, yeah, ordered pairs will always be a number, comma, another number. They'll be in a set of parentheses. And it's just your x, comma, y. So it goes alphabetically to x, comma, y. And you should be thinking that it's left, right, and then up, down. So you do the left, right part first, and then you do the up, down part second. Which again, hopefully this is all review. On your axes, the x, y, your x-axis and y-axis, your x-axis runs left and right, which is y. Whenever we have our whenever we have our two numbers, the x is first, and it's the left-right part, and then the y goes up and down, and the y-axis goes up and down. So the y part, you're going to go up and down. All right, so we're going to plot a couple of these. So 4, 8. So 4, we're going to do our left-right. One thing I didn't mention: you always start at the origin. So the origin is where the two axes cross, and that's your point 0, 0. So from the origin, we're going to first go, because it's a positive 4, we're going to go to the right 4. So from here, we're going to go over 4. So 1, 2, 3, 4. And then we're going to go up 8, because it's a positive 8. So 1, 2, 3, 4, 5, 6, 7, 8. And right there is going to be our point 4, 8. Okay, so we'll graph a couple more, and then I'll give you guys a few seconds to graph a few on your own. So -4, -8. The -4, am I going to go left or go right? Going to go left because we're going negative. So 1, 2, 3, 4, and then the 8. Yep. We're going to get, it's a positive 8, so we're going to go up, right? 2, 3, 4, 5, 6, 7, and there we go. So there we've got the point -4, 8. All right, what about -4, -8? What quadrant will that be in? Third quadrant, right. So we know the -4 is to the left, and the -8 will be down. And this is the third quadrant because we started here, right? 1, 2, 3, and then this will be the fourth. But the third quadrant is where we're going to end up. So 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8. All right, what quadrant will 4, -8 be in? Yeah, it'll be in the fourth quadrant. So we're going to go positive 4, 1, 2, 3, 4, and then down 8. And I'm going to cheat and just line it up, which isn't really cheating, it's just being effective and smart, right? Efficient and smart. Positive 4, -8. Thanks, guys. Again, always correct me whenever I mess up. So we got the positive 4, -8. I'll give you guys a second to go ahead and graph the rest of these. All right, let's talk about them real quick. So -5 or -0.5 and then 3.5. What quadrant do we end up in? And were you guys okay that it was -1/2, so it was just a little bit over? Okay. And then we went up 3.5, so 1, 2, 3.5. So that was our -0.5, 3.5. All right, the -9, 0. What quadrant did that end up on? No quadrant. What did it end up on? The x-axis, right. So we started here, we went -9, and then we didn't go up or down any. So we just stayed right on the x-axis. Which, what kind of point would that be if we had a line running through it? X-intercepts? Yeah, because if you anywhere you cross the x-axis, x-intercept? Yeah, okay. I know, I think we talked about that a while back. And then what about 0, 0? Origin, right. So if you have 0.6 or 0.8, you're still going through the same process. If it asks you to graph like a 0.6 or 0.8 in my math lab, it'll make sure that the graph is split up so you can do that. to where it'll have smaller increments, because I have whole numbers, so it wasn't too bad for me to guess on a half. But if you have 0.6 or 0.8, then my math lab's probably going to split it up by tenths, or maybe 2/10 or something like that. So it'll make it possible for you to do it. All right, so I want you guys to go through and tell me. So we already know the quadrants are 1, 2, and 3, and 4, right? So I want you to go through and just by yourself come up with the signs. So I'll give you the first one. So the x part, if you're in the first quadrant, will always be positive. And the y part will always be positive. So you guys go through and do the rest of them real quick. All right, so what signs did you get for the second quadrant? Yes, negative, positive. What about the third? What about the fourth? Very nice. This is actually pretty important to think about. This will help you with graphing, but also whenever it'll give you something weird, like weird fractions or decimals or something like that, and it'll ask you what quadrant, or it could ask you what quadrant. A lot of times students will freak out because they'll see something like a 16th, comma, negative 0.0026. And trying to think about graphing these itty-bitty tiny things kind of is weird, but you're only looking at the signs. If you're trying to figure out what quadrant you're in, as soon as you recognize what the signs are, you already know the right area to be in to graph. So you just kind of double check on everything. All right, everybody good with 1-1? Super. All right, so let's talk about 2-1. So this actually has a good bit of stuff we're going to go through. It's an introduction to functions. And we want to make sure that we talk about domain and range of a relation. So a relation is not necessarily a function, but we'll get there. And then determine if a relation is a function or not. Evaluate functions and use vertical line tests that we can just look at a graph and tell if it's a function right away. So I mean literally, maybe 5 seconds and you'll know. Maybe less than that if it's an easy one. And then also, just by looking at a graph, we can get all kinds of good information about the function. So, but first, let's talk about a relation. So a relation is any set of ordered pairs. The set of all first components of the ordered pairs is called the domain of the relation, and the set of all the second components is called the range of the relation. So we're thinking about it as your input and your output. The input is usually your x. So in your ordered pair, where your x would be, that's your input. That's typically the variable that you pick. So you can figure out your y so that you can get your output y. So again, so your domain is going to be your input or your x's, or where the x value would be in an ordered pair, and the range is going to be your output, or the area where the y value would be in your ordered pairs. All right, so just kind of graphically looking at some of these. So if we start with 0 and I go to 9.1, and I start at 10 and go to 6.7, and so on and so forth. Where we started, the input, the one we picked, is our domain, and then it tells us where we end up, which is in our range. And it can be just these little individual points like this, to where the range would just be the 9.1, 6.7, 10.7. It would just be that set of numbers. Or it can be a range, meaning it could be from all positive numbers. So you could have a range, all positive numbers, or all numbers greater than 0. Also, your domain and range, it doesn't necessarily have to just be numbers. It can be stuff. It can be names. It can be really anything, shapes, colors, whatever. All right, so whenever we look at the domain here, this is people and how much money they make. I think this is probably in the millions. So I'm guessing Simon Cowell and Tim McGraw both make $80 million a year. Anyway, but I wanted to point that out, that these two are going to the same place. And I also want to point out in this next one, because these are just relations, so in the next one, they swapped these. And they made the amount of money the input or the domain, and made the person the output or the range. So from the 80 million, it goes to Simon Cowell and Tim McGraw. So I just want to point that out. So to figure out if a relation is a function, you got to know what a function is. So a function is a correspondence from a first set, called the domain, to a second set, called the range, such that each element in the domain corresponds to exactly one element in the range. Sounds really confusing. What it means is that for every x value you have exactly one y value it goes to. So for every x value you have exactly one y value that it goes to. So for every element in the domain, you have exactly one element in the range that it goes to. So I want us to look back at these three really quickly. So these are relations, but now we need to find out if these are also functions. So for this first one, is this going to be a function? Yes, every single value in the domain goes to exactly one point in the range. So this one, function. All right, what about the second one? All right, we got a split vote on it. Okay, so Cowell, so because I'm sure this is the one you guys are looking at, right? The Cowell and McGraw going to the 80. So Cowell, the element in the x, does it go to exactly one element in the range, one element in the y? Yeah, so Cowell, Simon Cowell makes $80 million. All right, Tim McGraw. Does Tim McGraw go to exactly one element in the range? Yeah, we know Tim McGraw makes $80 million. So this one is also a function. All right, what about the last one? No. So this one's not, because if I tell you 80 million and I say which person makes $80 million, I expect you to be able to tell me. And you guys are not going to all give me the same answer, right? If I say you can only pick one, I'll probably have some of you say Simon Cowell, and I'll have some of you say Tim McGraw. Both right, but it's not a function. So if it's a function, every time you put an input in, everybody gets the same output, assuming that you don't make any mathematical errors. So this one, not a function. All right, so let's look at these. Actually, we're going to call these 4 examples. So A, B, C, and D. I want you guys to take a minute, think about all of those, and just kind of figure out to yourself if you think it's a function or not, and then we'll talk about them. All right, number 1, is that a function? Yes. What about number 2? Sorry, B. No, why not? Yeah. If we give you 6 as an input, you don't know what your output is. You're going to, kind of be hit or miss. So no. All right, what about C? And what about D? Did you all figure out C and D are just, yeah, they're just the pictures. But hopefully you thought about it separately. One thing I do want to do really quickly is I want us to graph A and B really fast. So I'm just going to put a really super rough graph in here. Let's see. All right, and then for A, so graph A. So A, we got 1, 6, so 1, and then 1, 2, 3, 4, 5, 6. We've got 2, 6, so 2, and then all the way up to 6. And 3, 8. I realize these are not beautiful, my apologies. And 4, 9, about right there. Okay, so those are horrible dots, but you get the idea. And now I want to graph B. So we got 6, 1. So 1, 2, 3, 4, 5, 6. We got 6, 2, 8, 3, and then 9, 4. So 9 was actually one more over. And that's a really bad 8, 3. Yeah, let's fix that. So 8 there-ish. A little better. And then 9/4 should be about right there. Now to kind of lead in, do you guys see where if we come over to the 6, we don't know which dot to stop on? So if I tell you 6, so this is for B, for the one that was not a function. If we go to 6, 6 stops at 1 and at 2. It's got 2 points whenever you go to 6. So if I were to draw a line, I would end up hitting both those points. Okay. All right, keep thinking about that. Well, we're going to come back to it. I just wanted to tease you with it. All right, so let's talk about functions as equations. So we need to determine, we might get an equation, and then we need to determine if it is a function. So basically, we need to determine if we can define y as a function of x. That's kind of how they'll phrase it. It's basically saying, is this a function? So we want to know that for every x we put in, we're only going to get one y value. So it's the same idea with the ordered pairs, that for every x, you're only going to get one y. But this time we're looking at it as an equation. I find it easier if we solve for y. So we go through and solve for y here. So we get y equals negative 2x plus 6. Can you all think of any x value that would give you two y values? Can you think of any x value that would give you more than one y value? How about that? So give you two y values or more. Well, if we were to square stuff, right, but then that's not the same function. Because what's this look like if you were to graph it? Yeah, it's y equals mx plus b. It's a line. So if you have a line, anytime you have an x, you always get one y out, right? Just one. So this one's going to be a function. All right, b, let's solve for y in part b. So to solve for the y, we're going to move x squared over. So we've got y squared equals negative x squared plus 1. Okay, so I'm there almost. How do I get rid of this squared? Yeah, we're going to take the square root of both sides. So now we take the square root of both sides. We're going to get y equals, and then tell me what I'm intentionally not writing there that I need to write. Plus or minus. So now, if I pick an x value and I plug it in, am I going to get more than one y value? How about this? Pick an x value, think about it. Put an x value in there, see what you get for y. So let's put in x is 0. So if we put x is 0 in there, what do you get for y? 1 and negative 1. Right, that plus or minus, right? It gives you two values. So if you put in x is 0, you're going to get y is 1 or y is negative 1. Because you're getting two y's, not a function. Does anybody happen to know what this graph looks like? Sorta. Well, it's a conic. Right, so that would be if it was just y squared but no x squared. Or no, either way. If there was an x squared and just y, or y squared and just x, it would either be a parabola that was upright or a parabola on its side. Because this is x squared and y squared, this one's actually a circle. So it's just a circle with a radius of 1. So it's going to look like that. That's a really bad circle, but you get the idea. All right, let's talk about some function notation. By the way, the big trick with these, if you have a y squared, chances are you're going to end up not having a function. Also, if you have absolute value of y, which I didn't put that one up here. If you have absolute value of y, let's think about it. If I have absolute value of y equals x. If I tell you x is 3, what's y? Right, it'd be minus 3 or plus 3. So if you have absolute value of y, or if you have a squared y, you're not going to end up with a function. So look for those, but also just think about it, because if you can come up with one example where you put an x in and you get 2 y values, that's enough to prove it's not going to be a function. Is that okay? All right. Hopefully it's so easy you're bored. All right, so let's talk about function notation. So we already talked that x is your input. Instead of y, we're now going to say f of x, and that's how this is read. So f of x, and of a lot of times means parentheses. If I say I'm trying to think of a good example, because a lot of times of will mean multiply. It doesn't in this case, but f of x is just going to be the f parentheses with the x inside. So f of x is the replacement for y in a function. F of x actually tells you a lot more. So if you see f of x equals something, it's telling you it's a function of x. It also comes in really handy as you get towards the end and start plugging in values. So if we used to have, if we had y equals 2x plus 5, and we wanted to plug in 5 for x and work it out, we would get 15 for y, and we have our ordered pair 5, 15. Well, with f of x, to me it makes more sense. So we go through, we have our f of x and we have our x, right? So the 2x plus 5. Whatever you put in these parentheses, so where that x is, whatever goes in those parentheses, you're going to put where the x is on the other side. So where we did f of 5, we're plugging in a 5 for the x. So here, 2 times 5 plus 5 is 15, and we would write it f of 5 equals 15. So that's how we're going to read this. So f of 5 equals, or is, 15. And it's going to be the ordered pair 5, 15. So it's in order now, right? It starts to hopefully make a little bit more sense. Sort of, kind of, maybe. It's a lot less complicated than it seems. As soon as we do one or two, you guys will have no issue with it. Or maybe it's still review and you have no issue with it and you're just bored and that's why you're quiet. Okay, so let's evaluate some of these. So for the f of x, if I tell you f of x equals 3x plus 7, and I say find f of 4, what are you doing? Yeah, you're going to multiply 3 times 4 and then add 7. My suggestion to you, so whenever we're doing the f of 4, I'm thinking it's f of whatever equals 3 and then times the whatever plus 7. So I'm doing f of 4. I need to plug in 4. If you leave the parentheses where your variable was, this will save you dearly from those little tiny mistakes you make, those sign errors you make, or maybe a distributing mistake, things like that. So f of 4, yeah. So the 3 times 4 is going to give us 12 plus 7. So we get 19? Yeah. Okay. All right, so f of 4 is 19. The ordered pair that would coordinate with that would be 4, 19. All right, so B is a little trickier and C is a little trickier. I want you all to try both B and C. I'll give you a minute. And what you're doing, you're going to plug in what it says to plug in. So you're going to do the f of x plus 1 and the f of negative x, and then simplify it if you can. So you're not going to solve and get a number with these, but you are going to try to simplify it. So for B, did you all plug in the x plus 1 with the parentheses? Okay. Did you see why the parentheses were really important in this one? Yes, because that distributing thing. So hopefully your next line is what? Yes. Thank you for taking out the extra step for me. All right. And then our final, so f of x plus 1 equals what? Yeah, 3x plus 10. Is that okay? This one you wouldn't. Yeah, so this one you're not going to have coordinates for. Very good question. Uh-huh. Oh, on the left side? Yes. No. So on the left-hand side, you're going to keep it f of x plus 1. That's a great question. So basically, the f of whatever is going to stay f of whatever through the rest of that problem. If you were to take it back to f of x, then you just changed your input. So and what this is saying is that if we have a function, and we have the function 3x plus 7, if we plug in x plus 1, we're going to get 3x plus 10. Because if we plug in x, we get 3x plus 7. So with the negative x, how did you all simplify that on the next line? Yeah, negative 3x plus 7. So f of negative x equals negative 3x plus 7. Is that okay? All right. And give you another like minute. Let you try G. So G is a little bit more complicated, but it's the exact same idea. If you go through the process, putting parentheses, you should be able to make it through. All right, most of you guys look done. So for A, again, hopefully you wrote it with the parentheses everywhere and then plugged in your negative 1. So G of negative 1. My next line, I'm going to have G of negative 1 equals, what's negative 1 squared? Positive 1. You all that used your calculator forgot to put parentheses. So again, parentheses are super important. This is the perfect example. If you didn't have them around there, you're going to get the wrong sign. So negative 1 times negative 1 gives you a positive 1. All right, and then negative 10 times negative 1, positive 10, and then minus 3 is just a minus 3. So when we simplify, we get G of negative 1 equals what? Yeah. Equals 8. That one okay? Yeah, we can. So what are the coordinates? Yeah, negative 1, 8. So we want to go plot this, which a lot of times you'll get a function and it'll say graph it. And if you need to plug in some points so you can graph it, yeah, as soon as you get to the G equals, G of negative 1 equals 8, you know it's going to be negative 1, 8. Right. Okay, well, yes and no. You can. It's going to not be a point. It's going to be like a line or a parabola. It's going to be a shape or a curvy line or something like that. So you can still graph it. You can still graph it. Like I said, it just won't be an ordered pair. And actually, I guess we will eventually do that. So B, did you guys plug in the x plus 2 in all your parentheses? Okay. I'm guessing you saw where the parentheses were really important here also, right? Okay. So we got G of x plus 2. Whenever you foiled or whenever you squared x plus 2, what'd you get? Uh-huh. And then whenever you distributed that negative 10, yeah, minus 10x minus 20 minus 3. All right, and then we're going to simplify, so we're going to put together like terms. So G of x plus 2 equals, what's my first term? X squared. All right, so we got this one taken care of. But now we need to get the x's together. So I got 4x and minus 10x. Minus 6x. Okay, and then we've got the 4, the negative 20, and the negative 3. Negative 19? We all in agreement? Okay. So this one's not going to have coordinates, but you could graph the x squared minus 6x minus 19. This would be a parabola because of the x squared. And this g of x plus 2, the g of is like your y. All right. So part C, also a good example where your parentheses are important. Let's see if we make it through. So g of negative x equals, what's negative x all squared? x squared. All right, minus 10 times negative x. And we're going to keep that negative 3. And then we're done, right? So if we wanted coordinates here, we would just be graphing the x squared minus 6x minus 19. So we would be plugging in values, and we could still do it, but we're going to have to pick values of x and plug those in at that point. Because again, we'd be treating this like a y, or what we would more than likely do, instead of calling this a g of x plus 2, we would call it a new function, like maybe h of x, which, and you guys didn't even flinch at this, which is great. So the top one we were using f of x, the bottom one we're using g of x. It's just function notation. It doesn't matter that we're using f or g or h or l or whatever. You probably won't use l because it looks like a 1. But anyway, you can do whatever of x and it's still fine. Yeah, so like if you wanted to go through, and this one, like I said, this one's a parabola, so it wouldn't be linear, but like if you wanted to graph this one, pretend, so to graph it, instead of having the g of x plus 2, I would do a substitution. So maybe I would pick, I would do something like g of x plus 2 equals h of x. So, and then that equals the x squared minus 6x minus 19. And then whenever we're graphing it, we're just looking here, where we're just going to pick values of x, plug it in, let it spit it out, and we can go ahead and graph. Yeah. Good question. I made it up. Yes. So I decided, instead of having g of x plus 2, instead of having g of x of that, all that stuff, we'll just make it easier and make it h of x. So it's no different than f of x or really any other sort of substitution. Try not to explain it to the point it makes less sense, so I'll stop. Oh, okay, so here, if we wanted to pick a value of x and plug it in, we could do that. So here, how about let's give you guys an example. You want an actual example? Okay. So here will be some very bad graphing. All right, and let's say we want to look at, so completely separate, we want to look at g of x equals, I'm going to pick a line just to make it easier for me, so 2x minus 3. All right, so g of x equals 2x minus 3. So I've got the y-intercept of negative 3. I have a slope of 2, so I'm going to go up 2 over 1, up 2 over 1. I only needed 2 points. I made 3 just to kind of give myself a little bit better of an idea. And we're going to hope, there we go. Not completely awesome, but it's a line. So now, let's do g of x plus 2. Is that okay? So we're going to do 2, leave some space, minus 3. We're plugging in that x plus 2. So we get our g of x plus 2 equals, so this is going to give us the 2x plus 4 minus 3. Are you guys okay if I go ahead and do the plus 4 minus 3 all together and get a plus 1? Okay. Is that all right? Okay. So now to graph this guy, I have a y-intercept of 1, and I still have a slope of 2. So I'm going to go up 2 over 1, up 2 over 1. So now I've got this going. So if I wanted to label it, I could call this g of x plus 2. And this guy was g of x. Or I could have said h of x equals g of x plus 2. So I'm just calling it, I'm just giving it another name. I'm trying to give it a more simple name. So then I could have also called the purple line just h of x if I wanted to. Just because I gave it a new name, I wanted to have a shorter name for it. Is that all right? Sort of, kind of. After you do 50 million, be cake. All right, this is a super fun, easy page. So, vertical line test. You know how earlier we actually plotted the points and I made the big note about the one that was not a function. If you went to 6, you'd hit 2 dots if you went straight up. Okay, I know it's been like 20 minutes. So vertical line test is the best thing ever. If you can draw vertical lines everywhere and each vertical line only hits the graph one time, function. If you can draw a vertical line any place, so just once is enough, any place, and hit the graph twice, not a function. So for A, if I draw vertical lines, am I going to hit the line more than once? Am I going to hit the... Yeah, and that's about everywhere, right? So there, I hit it twice, not a function. For B, if I draw vertical lines, am I going to hit it more than once? Nope. So this one is a function. All right, what about C? Yes, it's a function. Because yes, if I draw the vertical lines, I only hit once. So function. What about D? No. And again, you'll have to be able to draw. If you do it one time, it fails. So not a function. And then for fun, this guy. It's a little tricky. So if I draw the line over the whole line, then I've hit it more than once, right? So if I draw the line over the line, I've hit it like a bazillion times just right there. So not a function. That's the one that tends to trip people up. If they see a vertical line, they think because it's a very simple graph that, oh, it must be. Vertical lines are not going to be functions. Everybody good so far? Okay. All right. So there's a lot. We only have one page, but it's a lot of information on one page. So we're going to talk about all the information we can get from a graph. I do want to mention set builder notation. The reason this is important, we're about to start talking about the domain and the range, where we can look at the graph and we're going to give a range of values. So we're going to say from whatever, x is 2 to x is 7. The graph is there, so that would be your domain. Your domain is all the x values. So looking at a picture, you're looking for all the x values that the graph covers. Okay, and then for the range, you're looking for all the y values that the graph covers. Does this make sense, this little picture up here? So to find your domain, you're looking for the x values, and to find your range, you're looking for the possible y values for your function. All right, we'll come back to the set builder notation. I want us to actually start pulling out domain and range first. So for this one, for number 1, the domain, all the possible x values go from what to what? From -2 to 1. So we're just looking for the x values, and it goes from -2 to 1. And these are filled in dots, which means that they are including the endpoints. Do you guys remember interval notation? Right, so the open close is whenever we're graphing it, but now we're going to take it to like shorthand. So if we want to have that the domain is from -2 to 1, -2 to 1, including the endpoints, we're going to use a bracket, -2 to 1, and then a bracket. The brackets include the endpoint. So the brackets are kind of like the filled in circle, okay? We'll talk about it more in just a second, but the range, sorry, not the range. If we didn't use a bracket, if we used a parenthesis, which we're going to use in a few examples, a parenthesis does not include the endpoint. It just means that it stopped there and didn't include it. You can have, right, it can be one of each depending on how things go. So that's going to be like an open circle. And we'll get there. We're going to do a lot of these in just a second. We'll see how number 1 goes, and we might do a lot of those and then finish up with 2 and 3. So the range, what are all the possible y values? And this is actually a little bit trickier. The range is normally harder than the, okay, maybe it was not that tricky. So from 0 to 3. So are you guys including those endpoints? You are. So the range, 0 to 3, you're going to have brackets because you're including the endpoints. Another trick with interval notation, the smaller number always comes first. So a lot of times I'll see students on graphs that are a little bit more complicated get the right numbers but in the wrong order. So the smaller number always comes first. All right, and then let's do f of 0. So normally it's f of what? Yeah, it's normally f of x. So what f of 0 is saying is where x is 0, what's it equal? So at x is 0, if I go up and hit my graph, I get a value of 1, right, for the y? Do you all see that? So this is saying whenever x is 0, so whenever x is 0, we're going to go up and hit it, and we get the point 0, 1. It does, and that's actually a great comment. So whenever we're using interval notation, especially whenever you're going to have parentheses on both ends, it's going to look a whole lot like an ordered pair, to where you really need to know what's going on. So definitely in your notes, label things well, right? So go ahead and put down that you're doing the domain, that you're not listing an ordered pair and things like that. So yeah, very good comment. Now this one's a little bit trickier. F of what gives you 0? F of negative 2, right? So we're looking for the y value of 0, which is along this, and it's going to be at this point right here. So f of negative 2 gives us 0. Is that all right? Yes, ma'am. So the 0 being on the x-axis, yes. This is where y equals 0 is the x-axis. And the line is touching, our graph is touching the x-axis at the negative 2. Does that make sense or no? Sort of, kind of? Okay. And a lot of these, once you play with them for a little bit, they'll click for you. One of the ways to think about it is that whenever you're solving these, you're going to be listing, or you should be giving, an ordered pair that's on the graph. So negative 2, 0 is on the graph, right there, and 0, 1 is on the graph. So do you guys see the 0, 1? Yeah. Okay, so the f of something is going to be 0. Whenever you have f of whatever, so if we do f of what will give us 3. That'll be a nice one. So f of what gives us 3. Remember, the f of x together is the same as y. So this is saying where y is 3. So y is 3 here. What was the x value? So to be on the graph, we have the point 1, 3. So that means my x value has to be 1. So it's kind of going backwards right there. All right, I'm going to take a pause from these. We're going to come right back to them. But let's go talk about notation real quick. We're going to do interval first, and then we'll go hit the set. So interval notation first. And I'm just going to do line graphs really quickly, because line graphs are quick. So if we have something like and you all are used to seeing them this way, I think, with the open and closed circles, right? So I want to do interval notation for that red line. What would it be? Okay, I'll help you. But what goes in front of the -2? Parenthesis or bracket? Parenthesis. What goes after the 6? Right. Let's do it again. Let's see, 9 to 11, and we will make them both open. Yeah, both parentheses. Okay. Now let's start to make your word a little bit easier by making it a little bit more difficult temporarily. We are going to do away with the open circle and closed circle. So from now on, whenever you're graphing on a line graph, you're going to actually use your parenthesis or your bracket. So if we have something, so 6 to 10, and if I do parenthesis at 6 and bracket at 10, interval notation becomes super easy at that point, right? Because you already kind of labeled everything. So parenthesis, 6, 10, bracket. So then life's super great. So open and closed circles are gone. It's only going to be your parentheses and your brackets from here on out. But again, it just makes your life so much easier. Okay. It did not. It did not. So parenthesis was an open circle, which means don't include the endpoint. And bracket is the same as a filled in circle or a closed circle, which means include the endpoint. All right. Well, that was a quick catch up. All right, so there's your interval notation. Again, we'll talk briefly about set notation. I'm going to go back to here. So set builder notation, you're going to start with braces. And braces are the little crazy squiggly guys, right? So that's a set of braces, and one of them will be a brace. And it's read, the set X, or whatever's there. This line, just an up and down line, means such that. And then you give it the rest of the information using inequality signs. So coming back over here, we want to do these guys in set builder notation. Then we're going to have, and I'll start you out, the set X such that we need to be between -2 and 6, right? Okay. So there's going to be a -2 then some inequality sign, an x, and a 6, and then we're going to close our set. What inequality sign goes between the -2 and the x? Less than. So these get a little tricky, right? So less than. All right, and then what goes between the x and the 6? Less than or equal. So they are a little bit tricky. One of the things to know is whenever you've got set builder notation, if you have a variable in between, or if you have a compound inequality, which is what this is with the 3 parts, your signs have to face the same way. So what this is saying is that -2 is less than x, and x is less than or equal to 6. So you're kind of thinking about it that way, but it really just means that from -2 to 6. I want you guys to try the other 2 with set builder notation. So I'll give you 30, 40 seconds. Correct. Because it's open or because of the parenthesis, you can't have the equal. Very good question. All right, for the second one, the set x such that, and then what number do I have first? Okay, then what symbol? Less than. Just less than. Because it's parentheses on both, it's just going to be less than. There's no equal. If you have a bracket, you're going to have an or equal. Okay, so if it's just parentheses, then it's only going to be a less than or a greater than. You're not going to have or equal. If you have a bracket, you will have or equal, because including the endpoint or using a bracket means it can equal that number. Yes? Yes, it could be greater than, but not with, well, it could be, but it would be a line going infinitely in one direction. So we will get there. All right, and then this third one, the set x such that, what's your first number? Symbol? All right. Nice. 10. So you got the or equal to in there, right? Okay. Let's go pop back and finish this page really quickly. So let's go back to domain and range, and now writing the domain and range is hopefully easier in interval notation, because interval notation is short. I will be asking you all for interval notation 95% of the time. So the domain for this guy, all the x's. What are all the x values for this graph? Yeah. So less than or equal to 4, because it goes forever, right? Well, what's negative forever? Negative infinity. So interval notation for the domain is going to be negative infinity to 4, because again, the smaller number first. Negative forever is smaller than any other number, right? So negative infinity is smaller than any other number. It'll come first. The 4, does it get a bracket or a parenthesis? Bracket. Now this is a little tricky. Negative infinity, bracket or parenthesis, what do you think? Well, we got to give it something. It'll be a parenthesis, because you can't ever touch negative infinity, right? So -4, you get to use. You can touch it. So you get a bracket. You're using that endpoint. Negative infinity doesn't really have an endpoint, because as soon as you're there, it's further. Yeah? So we recognize that we can never touch the negative infinity. Same's true for positive infinity. So the infinities will always have parentheses. All right, so we got the domain. The range on this one's a little bit tricky too. So what's the range? So the y values, I'm here in 0, so you guys are recognizing that whenever y is 0, the graph starts, or there's an endpoint there. And then is it going to be positive or negative? Yeah, positive. Because it goes, the graph is going forever, kind of in an upward way, right? To the left, but also up. So it's from the 0 to what? To infinity. All right, we already know the infinity gets a parenthesis, and the 0, bracket. Okay, so f of 0 is what? So f of 0, that's the x is 0, is 2. All right, and then f of what is 0? Yeah, f of 4 is 0. All right, one more. And this one is sort of easy and a little tricky. So domain on this guy. Okay, so I'm getting that the x values are from the -2 to 1. And then tell me again about your parentheses and your brackets. Yeah, bracket and parenthesis. Is that okay? All right, this is the one that might be a little tricky. Range, so your y values. 1 to 5. Okay, it was not tricky. Good, good. Yes, a lot of times people are going to want to go up here and use this endpoint, but it doesn't have to be an endpoint. Well, we're going to use brackets actually. So the 1 is on the graph, so we're including it. So because we're including it, it's got to get the bracket. And then the 5, it's got to filled in, so we're going to use it. Is that okay? Okay. All right, f of 0 is what? Yeah. And f of what is 2? And there's only one correct answer. And that is not it. -1. It doesn't actually equal 2 here, right? Because there's an open circle. That endpoint's not included. See, it was that there was the really tricky part. So we got to go over here. Here's where the y equals 2 and it's on the graph is this point, which is going to be at -1. So f of -1 equals 2. That was a really tricky question, but I just couldn't help myself, so I put it in there. All right, any questions on that? Any of that part? No? All right. Please realize we just covered a